Hello and welcome everyone to our 22nd FAIRWork webinar. And today our colleague Johanna Lavigi from the Werkzeuglabor of the RWTH University in Aachen will introduce to you the AI side of our project. So what AI approaches to be used, how we use them, and how we integrated them in a service-oriented approach so that we can support our flexible decision-making in FAIRWork. Without further ado, I hand over to my colleague to start the interest presentation. Thank you very much.
Thank you, Christian. As Christian already said, my name is Johanna Lavigi from the WZL of the RWTH Aachen, and we are partners in the FAIRWork project. And today we will talk a little bit about our AI services and how we can help decision makers to make decisions, especially in production environment, and how we can support them. Our AI services are a service-oriented approach, but let's start a little bit with what is FAIRWork about. Maybe you have heard already a little bit in the other webinars, but just a short introduction, what we want to do. And in the end, somehow, let's break it down to we want to help decision makers in decision making somehow. And the part we are focusing on today is the AI enrichment of this support. So how can we use AI to support decision making? So this is the part where we will focus on, and the question is now, which challenges are coming up, especially in complex production environments, and how can we support there with which information and which knowledge, and how can we process the knowledge? So let's talk a little bit about the challenges in general we considered in the production environment. And for FAIRWork now, we have focused on 7 challenges. These are the ones I have listed here. And we will go through them step by step. And for all these challenges, we developed AI services based on different AI algorithms and backbones. For some, we will go a little bit deeper into the details, and some we will just have a broad overview. And at the end, I want to tell you a little bit about what you can do now with the knowledge I share with you here, and how you can also have a look into maybe the algorithms we created. So let's start with the fair worker allocation. Why do we even consider this? Worker allocation is usually something where we allocate the workers to the machines and tasks that need to be done. And in this case, we want to include the human as a factor, as we also have the human that we want to allocate to the machines. So for us, we also consider the preferences of the humans that work there. And this is the situation you can see here, for example, is there are different machines and workstations, and there are humans allocated, and some of them are not so happy because they say, for example, I don't really prefer working here. I don't like it here out of some reason. Or maybe also it feels too hard to work here. And this is another thing. This is not the preference we consider, but this is also the resilience we consider additionally to the typical work allocation, and that our algorithm considers. And the resilience in the end means how hard is it for each worker to work on which station. This is especially important if it comes to work where the strength of a person is especially important, because you might have to lift heavy things. The next step from there is the production planning. And for the production planning, actually the work allocation is a part. The production planning goes in 2 steps. And this is also where we're going to have a little bit of a deeper look in a moment. And since the work allocation is part of this, you can also see the results for this in a moment in the live demonstration. Because the production planning makes 2 steps. First, it gets the orders, and then it creates the work allocation. So let's take a little deeper dive into this production planning. In the first moment, we have the orders for the worker allocation. For the schedule for the machines, the work allocation is what we do after this. So we get the orders. For example, we know which product needs to be produced, in which amount, to which due date, how much time does it take to produce this order, maybe on which line can it be produced, because maybe it cannot be produced on every line of the production. We also know the priority of this product order, etc. And from this, we want to make, in the end, we make a machine plan, a schedule, which product or which order will be produced on which line. And we take this output then and use it then in a worker allocation in the next step. There we include also the worker availabilities. So for example, the shift plan, etc. And also have some worker constraints, because maybe some workers are not trained on each machine and is not allowed to work there. And there's also where we include the preferences and the resilience of each worker, and then make a whole production plan. Whole production plan means on which machine, at which time is which product produced, and who is working on that machine in which shift. And we used different algorithm for each step. And of course, we reused for the second part, we reused what we have from the former worker allocation. So let's have a look into the algorithms. I will switch the screen sharing, just a quick second, and show you what we have and what the output is. Just a moment. Go. So I hope now you can see my browser. And in this browser, we have the interface, how we can currently use the algorithms we developed to test them and to validate them. And here I can select a schedule. There's a specific way how it needs to be designed. There's a table that we can include, and that includes all the information that are necessary. I already put it in here. But of course, then if you think about different production, etc., you always have to think about what information are relevant and what to include. The start date here is at the moment in 2023. The reason is the example schedule we have has dates in 2023. That's why we now will calculate a table for the past. However, it will work the same if we had like newer orders, but we wanted to be as close to the realistic environments as we can be, and we of course we couldn't get like the today orders for the testing, but we needed to use older orders for that. So we make like this little twitch in the validation. So we start from, like, we say, okay, we plan for the 8th of September in 2023, and we can make a day, we can make 2 days of plan. We could also make like a 14-day plan. Since the 14-day plan takes a little longer, we will leave it with the 2-day plan. And here we can use, we can decide which algorithms we want to use. All the algorithms have different pros and cons, of course, but we have all in all together for the worker allocation. We have constraint programming algorithms, we have reinforcement learning, and we have a Monte Carlo tree search. I will for now stick with the reinforcement learning approach because it works quite well. And here we have like different focus we can use, because in the algorithms we use, we could make different things different important. We can say, okay, we want to have all factors balanced in the end, but we could also say, okay, we want especially the experience of the worker to be considered. The experience of the worker must match the schedule we want to do. We can also say, okay, we want to have a focus especially on the preferences of the workers, or maybe we want to have the focus especially on the resilience. So how hard it is for a worker to work on which station. For this, I chose the reinforcement learning with the resilience, but of course you could also switch. And for the order allocation method, we have only the constraint programming approach, and there we can focus either on the tardiness or the make span. So think about, okay, how far do we break the deadlines? Or do we rather want to focus on that each machine is like used continuously instead of with a lot of breaks, so that we have a nice make span? In this case, I have the focus on the make span, and then you can press trigger AI service. I already did that before because it takes some seconds to calculate. So we'll show you what came out here. And this is, for example, here we can see how well we have fitted those factors, in this case, the experience, the preference, and the resilience. And from this, we get the output in this form. And for example, you can see on line 20 on the first day from 8 a.m. to 4 p.m. So in the first shift, there's produced the product 1, 4, 1, 3, 4, 2, 2, etc. And if we go down here, you can also see which workers are allocated to this. Of course, we can make this even a nicer list and user interface, etc. But for validation purposes, this is good enough to test how it works. I will now switch back to the presentation. Just a second. Here we go. And to be honest, of course, also now we are validating all the approaches. Let me tell you a little bit of the weird struggles that always come along when trying these out. For example, we recognized that our calculated outputs are always 1 hour off. So our calculated outputs always say the workers maybe work from example from 9 to 5 instead of from 8 to 4. And what happened probably was that in one part of the algorithm and one part in our backend, the time zone was not considered. While in the output, where if I trigger a service and then I have like this two problems, so that in this case, for example, this doesn't match. These are, of course, things, they come up and then you can fix them, but this is like just some of the I would say rather funny things that could come up. What also happened is that our output plan was maybe in some points not good because the amount of workers for a machine we needed to have was not enough. So for example, for one product, we need 3 workers to make them, but we only had 2. And looking into that, then we realized we just for this shift, there's just not enough workers. The shift plan doesn't allow us to have enough workers there. And this, of course, we can use as much AI as possible. If we don't have enough workers, we don't have enough workers. AI will not change that. However, we can use AI and the decision-making and make it more democratic and more fair, so that we maybe make a better environment, so that maybe more workers want to work there. Let's have a look into some of the other services we have thought of and we created algorithms for within the project. Oh, we already did that, but we can change to the next one. One challenge that can come up in production environments is the delay of material. And of course, this can especially come if products come or need to be delivered in boxes of different sizes and geometries, etc. And especially in B2B businesses where you have bigger orders, not maybe only 1 or 2 boxes, you want to also bring all the order maybe in 1 or as less as possible truckloads. So to optimize this material and container allocation, we included an automated we created an algorithm, and this includes an automated adaptation to orders and to changes in orders and truck availabilities, for example. Another thing we considered was the machine maintenance. And why and what does this mean? Well, machine maintenance means machine has throws an error and the technician comes and needs to fix it. Dependent on the machine and the production side, it can be that those errors are very diverse. The problems that come up are very diverse and heterogeneous. And not every technician might have seen all of the errors and problems before. And this is why in most production sites, they try to keep some kind of knowledge base for this. So for example, they have a database where you can find support for this problem, what needs to be done. But they need to look through them, and then maybe there's a second database where from other environments, they could put different information in there. And to look through all of this can take a lot of time. And in production environment, each second, depending on what you produce, can cost a lot of money, or at least each minute. So if you think about that, it's important that the technician is able to look into or to get the knowledge he or she needs to solve the problem as fast as possible. And we use large language models, for example, for this, to look through knowledge bases and wikis, etc., to find the information necessary as fast as possible. Another way how AI can support in production environment is if you think about document transformation. And actually this is more of like a base of what we then can do to create even more data, to use even more AI. Because in the end, what it is and what it's about is digitization. So it feels like a step before. But we all know we want to digitalize because we can use it and make more things possible. But we also know not all production sites and things and processes are digitalized because it's just a lot of effort to do that. And sometimes you need the knowledge from before, and this is still paper-based. And this means digitization in this case also means converting old documents into digitalized formats. And to help in transforming old paper-based documents into newer digitalized formats can then help going through the process of the digitized production and enable further automation of AI systems. And for this, we also used large language models. Another point where also AI or large language models can come in handy is find yourself around a diverse jungle of regulations. In this case, it is mainly about regulations that come in the clean rooms. Because the regulations in clean rooms update regularly. And people who use them on a daily basis, either they don't check them all the time, or maybe in different setups, they need to follow different regulations, so they would need to check it all the time. And then they would need to find the right document at the right moment for the right setup. And this takes time and is tiring. And this, of course, also means errors can just come up, because finding the right document and the newest version means you need to know what the newest version is. And this stress for either checking and comparing the versions and situations can often lead to mistakes and take time. So we also used large language models here to compare versions, etc., to present the most relevant rules to the human who will enter the clean room. So the person knows what to do and how to do it before entering it without needing to go through all the documents by him or herself. And then there's one more thing we considered here. And this is the calibration of the document certification. In general, it's about sometimes documents have to be checked. In this case, it's calibration documents, but of course you can also transfer to other kinds of documents that need to be post-checked from humans regarding some, for example, inconsistencies or missing data points, etc. And for this, we use a rule-based approach that tries to check for the most relevant errors and inconsistencies and go through the document and already highlights and informs about these problems. So the human who's checking all the documents all the time, which can be a really tiring work, already gets some help with where to look at and where problems could be. And there make the decision on what needs to be changed. This is the general overview about the challenges we considered in the project and the services we provided for this. Of course, some can also be transferred, or many can be transferred to other production environments. As I said, for this, we worked with calibration documents, but of course, in general, it's about checking documents and seeing where inconsistencies and errors are. But in general, what do we need to consider when developing a system to support decisions in production environments? And there are 3 things we want to give to everybody who's developing such a system. And there's one, the very first one is to consider the factor human in automated systems. I often feel like should be known, everybody should think of that. On the other hand, then when you are really deep into your technical and your algorithms, it is also easy to lose sight of the idea that there's also a human using it, or a human that is involved by this, a human who is affected by this output. And bringing the human into this system also means that the system can get a lot more complex to develop and also to think of, and maybe sometimes to use. So don't underestimate the complexity that this additional factor brings, but also value it and use it so that you can actually have a system that really works and helps the workers, the decision makers, and makes a better working environment. And even some small supporting systems can have a big effect, but only if done well. If you, for example, transform old documents into a digitized format, you have the possibility then to use the data you now generated in a digital format and to have a bigger database to even develop more AI systems or other data-based algorithms that can support your working environment or your production. But if it doesn't work and only half of the documents are like maybe readable, it's as good as nothing. So also think of the small things, but really try to make it in a way that you can then create an output that really works for you and your environment and brings a benefit. This so much for the general things I wanted to say. But what now? What can you do with this? If you're really interested in what we did and how we did it, for this project, we have the innovation shop and on our website. So you can check out the website and check out the innovation shop. And there are links to documents that we created, that are reports, additional information, but sometimes even GitHub links where some of the algorithms are publicly available. For example, the production planning algorithm is available online on GitHub, and you will find the links in the innovation shop of the FAIRWork website. So feel free to look out for that. There's also always a contact person for each part there. And in case you have any questions regarding this webinar, please feel free to ask, and thank you for your attention.
Thank you for your interesting presentation and the insights in how we used AI in our FAIRWork project. And I will open now the floor to everyone who wants to ask some questions. You can now the experts here. So if you're interested in something, feel free to ask. So then thank you very much for joining. Our next webinar will be at the beginning of May, where our colleagues from MORE, especially Gustavo, who is also here, will present about agents and orchestration in FAIRWork. So how we use the agents and how we accomplished orchestration of the AI service that Johanna introduced today. So then, thank you very much. Have a nice day, and hopefully see you at the beginning of May. Bye.
Bye.
Thank
Thank
you.
you.
Bye.
Thank you.
Bye bye.